Ideas in STEM Ed is a production of the Idea Engineering Student Center at UC San Diego, which works to promote community, success, and inclusion at all levels. My name is Darren Lapomi, Professor of Nanoengineering and Chemical Engineering and Faculty Director of the Idea Center. The purpose of this podcast is to provide a forum for the discussion of innovative and inclusive approaches to teaching and mentoring, and to support the personal and academic flourishing and success of students in science and engineering. To learn more about the Idea Center, visit jacobschool.ucsd.edu/idea. Lilo Pozzo is the Boeing-Roundhill Professor for Excellence in Chemical Engineering at the University of Washington. She is also a professor and the Interim Chair of the Department of Materials Science and Engineering. She earned her BS degree in Chemical Engineering at the University of Puerto Rico, Mayaguez in 2001, and her PhD in Chemical Engineering at Carnegie Mellon University in 2006. She obtained her current position at UW after a postdoctoral stint at the National Institute for Standards and Technology Center for Neutron Research from 2006 to 2007. Her research concerns the development, measurement, and control of self-assembly processes for soft materials over nanometer and micrometer scales. Current projects include high-throughput experimentation and data science for materials design, functional emulsions, and materials for energy conversion and storage. She is known for her excellence in teaching and mentoring, scientific and technological outreach to Puerto Rico in recovery after Hurricane Maria, and advocacy of LGBTQ scientists and engineers, especially trans and Latinx communities. We spoke in this episode about a wide range of topics. Lilo, thank you very much for coming on the podcast.
My pleasure. Thanks for inviting me.
Sure. How did you become interested in chemical engineering?
I come from a family of at least one engineer. So my dad is an electronic engineer. He's retired now. So I've always been exposed to technology in some regards. He used to work for this company called Olivetti, which most people know of it because they made typewriters, but they also made the first personal computers in Europe. So they were kind of like the IBM competitors in Europe, and he used to bring all kinds of computer parts and things like this into the house. And I think that was my first engagement with technology. He would do some basic experiments also. But in terms of chemical engineering, actually, that came out a little bit more in high school, and actually quite late in high school. For the longest time, I thought I was going to be a surgeon. I wanted to go into med school. And then in the junior year of high school, I had this great chemistry professor teaching, and he made chemistry super exciting. But yeah, I kind of matched my excitement in chemistry with my interest in technology and solving problems, and figure out that chemical engineering was going to be the right path for me.
Fantastic. Did you have any special problems as a kid, special projects or problems that you like to solve with these computer parts, like alarm systems for rooms and stuff like that?
My dad had a lot of confidence in us, and too much confidence, in fact, in terms of actually being safe with these things. He would show up with boxes full of electronic components. Sometimes there were motors that we could just run with a 9-volt battery, for example, and just play with them and make all kinds of gimmicks and things like that. But sometimes they were actually quite dangerous things, right? I remember once he actually came up with a power cord, right, that had actually been split into two, and my brother and I connected it, and it just started making all kinds of so you learned about electricity and potential and currents very quickly, essentially by trial by fire in these ways. So I wouldn't say that we were solving any kind of problem, but we were just playing with these things. Probably too much sometimes.
Mm-hmm. Reminds me of a time where I made a plywood robot and attached some throwaway electrical components that one of our family friends who worked at Kodak gave us. I grew up in the Rochester, New York area. And my mom said, "That's very, very nice, but don't ever plug that in."
Yeah, exactly. No, I mean, we had all kinds of, I mean, these are really great memories from childhood. I remember, like, back in the day, you used to get chemistry sets that were really all kinds of inorganic salts, right? Like many of them might have actually been dangerous in all kinds of ways, and we would just randomly mix them, hoping that something will happen, right? Like, and sometimes stuff did happen, but there was no logic behind it or instruction manual that we could actually follow, or none of the tools that I think students that are being exposed to chemistry nowadays, they're getting exposed in a much safer and controlled way, mm-hmm. right? Like there are nice, how do you say, kits that have a scientific question essentially guiding the activities and so on.
Mini labs.
Exactly, that did not exist for us. We were just randomly playing with stuff.
So going from randomly playing with stuff to doing stuff deliberately, can you tell us a little bit about the work you are currently doing?
So as some of you may know, or you may know, Darren, I am also super interested in soft matter, right? Like, that's how I grew up in the academic world. Anything that is soft and squishy, I'm just excited about. And I jump a lot, right, in terms of like within this area, right? Like sometimes they're polymers, sometimes they're gels, sometimes they're nanoparticles, and so on. And I really love this. I love this because it allows me to connect the dots and sometimes port technologies or materials from one place to a different area, and in this way be creative, right, about solving different problems. But the one thing that we're doing now that really, really gets me excited about the future is rethinking the way we do this science with materials. So we are actually embarking an adventure in the lab with really trying to integrate, algorithms like, machine learning tools, or essentially self-driving algorithms for designing experiments and executing experiments. And this has actually pushed us to think about how we execute our experiments. So we are using more robotic tools in the lab. We're analyzing data in much higher throughput. And this forces us to also think about how we extract knowledge from these much larger amounts of data that is actually flowing from our experiments. So I am really excited about this because I think that it is something that could potentially revolutionize our fields because we frequently have to break down really complex problems into just a few, principal components. And we kind of like oversimplify a lot of the problems, right, that we're tackling, because otherwise they would be really difficult to rationalize in their pure complexity. So by taking advantage of computers and high throughput tools that are already established in other areas, I think that we can take advantage of more statistical extraction of knowledge, right, from these data sets.
Is that a background that you had in computer science, or did you import the knowledge or take a sabbatical?
Not at all. This is purely coming out of seeing what a few laboratories have done and kind of understanding like, yeah, this totally makes sense. This is underutilized in soft matter too, and I'm just naturally inquisitive and try to. If something excites me, I'll figure out how to actually get into that area. And And it's been a very slow transition for us. It's actually the caveat to all of this excitement, right, is that it actually requires us to learn a lot of skills that we didn't have in the lab. And but I think that this is exciting, right? Because whenever you're challenging yourself to learn new things, it makes essentially the activities that we do and we engage in our everyday life so much more meaningful and interesting. So yes, I've learned about rapid prototyping. I've learned about designing tools in CAD. I've learned about 3D printing. I've learned a lot of Python programming. I've learned a little bit of machine learning, but way less than my students know, especially in terms of machine learning. So that's a skill I'm still actually developing a lot of. But yeah, I find that it's exciting because it really has also opened up new avenues of collaboration with teams from other departments that we would otherwise not have actually engaged with.
What are some of the downstream applications that excite you the most?
In terms of high throughput in this area, or just overall?
Overall.
So I think that there are so many problems, right, that we're going to be tackling, and probably our kids are actually going to be tackling and dealing with that really deserve our attention. But right now, I'm really excited about the prospects of using synthetic biology and reactors and separation processes that are going to have to be designed to make these type of new ways of manufacturing high-value products and chemicals viable. That's really exciting, and we have an NSF-sponsored project that in this area that is actually been extremely illuminating, again, because it forced me to learn a lot about what my colleagues are doing in the synthetic biology realm and how soft matter can actually help enable some of the challenges that they're dealing with. So that's an area that I'm really excited about. We are engaging also in essentially high throughput explorations of how do you say, conditions in the synthesis of nanomaterials affect the outcomes of the materials that you obtain, and obviously it has a ton of applications in clean energy, right? For solar cells, it has a lot of applications in quantum information systems, in sensors, and so on. So these are some of the things that we're working on right now. But I still also have a very special place in my heart for just trying to understand interesting materials, just because we just want to understand them and develop the fundamentals about them, right? Like sometimes there isn't an application necessarily driving this, and that's totally fine and also exciting, at least to me.
Of course. I know that you have an interest in global equity and ways that technology can be used to address problems in poorly served communities. And a couple of years ago, after Hurricane Maria, you were involved in was it a student project in environmental remediation or water purification?
What was it?
Maybe I have it wrong.
No. It's around the around this area. So, as you know, I did my bachelor's in Puerto Rico. I also was raised in Puerto Rico. I was born in Argentina, but I lived most of my life growing up in Puerto Rico. So I have a lot of connections to the island, friends, family members, and so on that are still living in the island. And yeah, when when the hurricane hit the island, like many other Puerto Ricans living here in the U.S., we were kind of like stuck, right, with wanting to help, and being an academic, I realized that the best way for me to contribute was probably not like trying to ship water bottles from Seattle, right? Like, and that maybe there would be something more meaningful that I could do, and that's where this project kind of came about. I saw students that were also equally motivated to help out. Like students are generally just want to save the world, so they're motivated, right? When there are challenges affecting populations across the world. And we were able to start this project that ended up being one of my, most rewarding experiences as an academic, because it's so far outside of my area of expertise. So I learned a lot in this project, and it also kind of like mixed everything that I like about life as an academic. It allowed me to provide a meaningful service, right, to the communities that we help, and I'll tell you a little bit about what we did. It provided me an opportunity to work with students that actually got an amazing educational experience from this. And it also actually ended up in 2 academically peer-reviewed publications that, so we did research essentially in this activity. And the focus of the project was to evaluate how small-scale solar systems, actually they're called nanogrids because they have storage, generation, and essentially conversion of solar essentially power, right, to electrical power that the users can use, but they're really, really tiny. They're even smaller than what essentially a house solar system would do. And we evaluated what was the potential of these systems being deployed in an emergency to satisfy the needs of families that had needs for power to sustain their healthcare needs. So there are a large number of populations that are extremely vulnerable because when power goes out, then they cannot actually get the healthcare that they rely on. This might be mobility issues. This might be, some families require electricity to feed their loved ones if they have essentially feeding tubes, right, because of their conditions, or just a gamut of different conditions affecting people. People that couldn't sleep because they had sleep apnea and their machines weren't working overnight. And those needs are normally met by the grid, but in an emergency, these families would otherwise have to rely on gas or diesel powered generators, which are noisy. They produce fumes. They're very costly to run and to maintain. So then we posed this question about like, what is the role of these small scale solar systems of being deployed during these emergencies? And we were able to essentially interview several families before and after they had opportunities to work with these systems, and learn from them about what were their challenges, what were the things that they liked and that worked really well, and what were essentially their overall thoughts about these systems. So.
Kind of an ethnographic interview combined with product market fit sort of. Were the students undergraduates or graduate students?
It was a mix of all, actually. I would say primarily graduate students, because it did involve travel to the island to go and actually perform these interviews. And a lot of the times the travel, we went to the island 3 times, and this was during the middle of the quarter. So, a few undergraduate students were able to manage to go with us, but the majority of them were graduate students. And and from multiple different departments, some from electrical engineering, some chemical engineering, some from essentially the med school, or so it was really rewarding from that perspective too.
How did you obtain the funding for the project?
Oh, we were really fortunate. The Clean Energy Institute here at the University of Washington provided us initial funding to travel, and kind of like the first trip was to identify and set the stage for our research questions, right? And then, we also were able to get funding from the Clean Energy Group, which is a nonprofit organization, to essentially purchase the systems that we were going to deliver to the families. And then there were numerous individual donors that also supported this project and enabled essentially the students to travel and for us to also purchase the things that we needed to actually help these families.
How would you
different sources?
Mm-hmm. How would you characterize the state of recovery of Puerto Rico now?
From the hurricane, it's done, like it's now, I would say, I don't want to say back to normal, right? But I mean, enough time has passed that a lot of the more acute problems have been tackled. The island still has a lot of challenges ahead, right? But these are more, I would say, chronic, right? Like these are issues that are unresolved, but that will take a lot of investment and a lot of time to actually resolve them. The electrical authority, I think, was going through major changes related to privatization, and there are challenges associated with this. There are still communities that are probably still suffering with inconsistent access to the power that they need. But largely, I would say that these challenges that remain, I mean, some of them might still be related to the hurricane, but some of them are more systemic about like just the situation in the island and sometimes decades of like management challenges, right?
What is education like on the island, particularly science and engineering education?
Outstanding. Like, to be honest, I mean, I had an amazing education, and I am so happy to have been able to get my education from a public university in Puerto Rico. And so I did my bachelor's at the University of Puerto Rico in Mayaguez, Colegio. That's and the university. I mean, I had access to so many great opportunities as a student there. I had amazing faculty in chemical engineering, also outside of chemical engineering. The education was virtually free if you compare it to the tuition costs in the US. But the quality of the education was just outstanding. And I love the fact that this made it so accessible, right, to a broad and very diverse group of students that came from all kinds of backgrounds all over the island. So this is something that I think the U.S. system is unfortunately unable to match, right? Here it's a little bit more segregated. You have like schools that are serving, I mean, let's say more diverse populations and populations that maybe don't necessarily have access to the resources that are necessary to attend to some of the more expensive schools. And that was not the case, at least in public education in Puerto Rico. It was really nice to actually have this opportunity that to get educated with such a diverse group of students. It's interesting because diversity is also kind of weird, right? Because we were all Hispanic, or most of us were Hispanic when essentially in the island. So diversity has a completely different meaning, right? When you're a student in Puerto Rico. But yeah, I look back at my years as a student there really, really fondly. And top-notch education. I think that when we came to do our PhDs here in the US, we did not feel like we were lagging behind.
Yeah, that's wonderful.
In any way, other than maybe the language, right? We had not had as much practice like living and speaking English on a daily basis, but yeah.
Sure. What have you learned about teaching and assessment from lecturing on Zoom? This is something we had a short conversation about on Twitter maybe 10 months ago. And I wonder how your thinking started and how it has evolved, and what lessons have you learned?
So I was fortunate to be teaching courses that actually did not suffer too much from the transition to Zoom over the last few years. So I don't know that my experience is uniform, right, with what others have experienced. But I actually learned a lot of positive things from the courses that I taught. I felt the students sometimes, depending on their background, whether they were undergraduate or graduate students, would engage in different ways. I felt that the use of Zoom presented new opportunities that I had not thought about as a faculty teaching in normal classroom instruction. So, for example, I could sometimes, for one of my introductory engineering classes, I could do experiments in my kitchen and actually showcase them, right? Which would have been a lot more challenging to do in a physical instructional laboratory.
Yeah.
Assessment is much harder, I think. Assessment, in my experience, was really, really challenging, and I don't think that at least for me, assessing in a traditional form, right, with exams or quizzes would have been very effective. So I tried to actually transition into more project-based or longer-term assignments for my assessments. But yeah, there are some lessons that I think I am taking from the pandemic that I think I would probably keep in my mind for even after we're out of this. Like sometimes some lectures and some material might actually work better in a digital format, and I also learned a lot about like what would it actually really take to do a flipped classroom, for example, which otherwise would not have crossed my mind, the possibility of actually flipping the classroom where you provide instructional material in video form, and then you use the class time, right, to help the students on a one-on-one or more close way to actually solve the problems and test whether they're actually learning the concepts and maybe clarify some of those doubts. Yeah.
One of the difficulties I found in flipping a classroom on Zoom is that, one, it's difficult to navigate between the breakout rooms without being pretty obtrusive or intrusive. You show up and nobody's talking because the professor's face suddenly appears in the breakout room. The experience of walking from one group to another because you can see what group might need help, and it's a little bit messier on Zoom.
I totally understand. I guess I meant more like before I would have not considered even flipping a classroom under normal circumstances, because I did not know, for example, how I had no access to, what does it actually take to record yourself and record a lecture? And the fact that it forced everyone to actually teach right in front of the computer and actually digitize some of your, it became less intimidating. Now I might actually consider it for future lectures.
Definitely an education in multimedia production.
Yes, exactly.
And some other sort of trivial things I think would be nice to have in person would be name placards, because it was much easier, I think, to learn students' names having their names under their videos or even pictures or avatars.
Exactly.
Is UW going to be in person or a hybrid in the fall?
The plan is for full in person, and that's what we're working with. So we're definitely preparing for a safe in-person experience for all our students, and I think that I'm pretty confident that we should be able to deliver. Again, an excellent, as close as possible, right, to normal in-person experience. Things will still look a little bit different, right? Like there is a mandate for vaccinations and essentially masking at this point, and things like this that are going to make it a little bit different, right? And like we're still not out of the woods. But the university is working really, really hard to make it an effective learning environment, and for our students to actually be able to take advantage of that in-person university experience that many of them have not yet been able to experience.
Mm-hmm. And you are starting as this fall, well, you've already started the position as Interim Chair of Material Science and Engineering. Is that right?
Yeah, not yet, though. I actually, next week I start my position.
Okay.
So, 1st of September. But yeah, I am starting as Interim Chair in Material Science.
Would you prefer that I say congratulations or my condolences?
I don't know. I'll answer that question in a month.
Okay.
No, it's intimidating and at the same time, how do you say? I feel honored that they thought of me as a person that could actually help with moving the department forward. And yeah, I do know it's going to be challenging, right? For me, this is the first major leadership role I'm venturing into. It's a different department than the one I started in as an academic. I do have a lot of connections with faculty in that department that I've worked with in the past. So yes, I'm eager to contribute and to help. But at the same time, I would be lying if I would say that I am not a little bit intimidated, right, by the challenges that are ahead.
Likewise, with my own recent foray into student affairs and directorship of our student affairs office, the Idea Center at UCSD. Speaking, this is a little bit of a garden path, but I think it will yield some interesting insights. If you were in a position to reform the way that NSF thinks about broader impacts or changing the criteria by which broader impact statements are judged, what would you do?
That's a great question. So I think the unfortunate bit is that broader impacts, everybody's expected to innovate and everybody's expected to essentially have a compelling, right, broader impacts section, right, and plan that goes beyond, right, what is usually expected. And things that are usually expected are, okay, you're going to be training and working with students, you're going to be doing work that will eventually impact society and so on. That's kind of like the garden, right, like kind of like what is expected. But frequently reviewers will expect to see more than that. They'll expect to see some creativity, right? They'll expect to see something that is kind of like pushing boundaries or thinking about, okay, well, what will we do differently to make those things happen even better, which is great. From one, like I actually think that being creative in broader impacts merits essentially a good evaluation, right? The problem that I see is that there's no reward system or checks and balances on what people are actually doing. So I could say that I am going to do a huge number of very creative, broader impacts activities as part of my proposal, but if there's no evaluation metric, right, about like whether I was actually successful at executing this or whether I even tried to execute this, then there are no teeth, right? I could say whatever I want in that broader impact statement, and I mean there is no checks and balances. In terms of the intellectual merit, there are checks, right? Like because you are essentially required, right? Like your CV, for example, showcases the publications that came out, right, out of your work, and the awards that you get usually from your intellectual activities and so on. So it would be great actually to reward, right, those that are really innovating in their broader impacts, that are actually doing innovative things like this podcast, for example, right? I think that this is actually a way that provides access or behind the curtains, right, to a lot of viewers that are going to benefit from this. And I think that would be one of the changes, is that if the expectation is that broader impacts need to be creative and novel and pushing boundaries, then there needs to be an evaluation criteria, right, that also checks on this, because I would venture to say that very few, a small percentage, right, of the proposers are actually being able to execute effective broader impact statements as they describe them.
Yeah. One issue is around logic and sustainability of a broader impacts project. If a PI is fortunate to get one NSF grant every 3 years, then in 15 years, do you have 5 concurrent projects? Also, the assessment piece is very difficult, and it's very expensive to do it well. People that do longitudinal studies of reductions in equity gaps and retention and yield rates, these take a lot of time. They take a lot of bookkeeping and a lot of hard analysis and survey data, and these aren't things that pretty much any PI in the engineering or physical sciences or natural sciences is trained to do, and yet it's a minuscule fraction of the budget as well.
Yeah, that's the other thing, is I think that either there needs to be resources, right, associated to these activities, or the expectation needs to be lowered, right? And that's kind of like what I was trying to imply, is that if you are evaluating everybody by what they actually are executing, then people are going to essentially like propose things that are realistic, right, that can actually be executed. If there are no checks, then you can propose like exorbitant programs that are just not going to be feasible to implement without resources. So I just think that there's a little bit of a mismatch there in between expectations and execution.
Speaking of mismatch, if you took a look at the federal research budget and you had to reallocate funds awarded to PIs for specific projects versus students and or postdocs for their own training, and they got to pick the project and the PI, do we have the right balance, or do you think it should be reallocated?
Absolutely not. Yeah, like I'm a big proponent of like funding the students. I think that this is something that I don't think that there is a perfect system. I think that every system has flaws and challenges. There are many systems in throughout the world that actually do fund the student through fellowships, the graduate students I'm referring to, so PhD students, for example. And I think that one of the things that these students really benefit from is that they own their path. So they hold the reins, right, of their training and education. So if a student is not satisfied, right, with the mentoring that they're receiving from their PI, then they have, right, the resources and they're empowered to essentially seek the appropriate mentoring or the opportunities for this. I think it alleviates a lot of the issues also that PIs like ourselves feel in terms of ensuring, right, that we always have streams of funding that are consistent with the students' thesis of research, right? Like, so it's very difficult, right, to essentially have a series of 3-year grants that are going to end up in a consistent topic to do a 5-year typical PhD thesis in a topical area that is essentially like the same, right? Like that allows the student to go really deep into those topics. Moreover, it alleviates some of the stress, right? Like one of the things that is really, really stressful for me as a PI is this fear, this constant fear of not winning the next proposal and essentially just I don't know, having to have attrition in my group or essentially having to switch a student, right? Like from their thesis research to, now we're going to work on this other project because funding wasn't successful in that. I just think it's, at the end of the day, the majority of our funding through proposals goes directly to the students. It is a much more streamlined process to directly fund the students. And that doesn't mean that you need to get rid of the proposal system for other things like equipment, resources, travel, PI support, and so on. So there's some good things about having competitive proposals also, right? Like it pushes us all to think more creatively and new directions. But I would love for the students to feel some sense of security for their studies.
Of course. So much unneeded adrenaline and cortisol is expended on a yearly basis as we try to fit these, 3-year grants into a 5-year PhD program. It's like playing Tetris, where you have to get this row of 4, but you only have these odd-shaped blocks, and you need to spin them in the right direction.
Inevitably, you end up with these Frankenstein theses, right? That have like 3 years worth of projects in one area and 2 years that are completely, hopefully somewhat related, but oftentimes different areas.
How does your mentoring style change when you're mentoring a GRFP-funded student versus a student funded on a grant, if at all? Or maybe not mentoring style, but project selection? I'll admit I haven't had a GRFP graduate student, but I've had students with other fellowships, right? Sure.
Like that are somewhat equivalent. And I don't think my mentoring changes in how I actually approach. I hope that I'm mentoring and providing the same level of mentoring.
Yeah, I think I misspoke there. I really mean project selection.
I understand what you mean. What I do feel the student does get that is different is that I feel like I am helping the student to sort out a thesis that is interesting to them and that I also kind of like I play a little bit more of a guidance into, okay, yeah, but how can we better define that problem? But the student, I think, gets a chance and an opportunity to participate more in the development of that underlying problem statement that is going to drive their thesis research. Whereas if I am mentoring a student out of a grant where I wrote it and it has a very clearly defined sets of goals and expectations, there's a lot less wiggle room, right, to essentially match the student's interests with what I decided was important to explore in that particular. So it gets to be a little bit more constraining and less creative, I feel. I feel like the students that are on fellowships have more wiggle room for exploration, which is, I think, oftentimes what leads to like just innovation and new areas of research. And students are so much more creative than we are in these situations that I feel like we're overly constraining them.
Yeah, I agree. So you are known, among many other things, as an advocate for LGBTQ issues among researchers. And I wonder if you could tell us a little bit about what special challenges or equity issues your community faces.
Yeah, so I'm part of the community. I am a trans woman, so I transitioned during essentially my career as an academic. So I've definitely experienced some of the challenges. Obviously, this is very different for different people. I think that some people have, I don't know, like, I mean, the LGBTQ community is so diverse, right, that you pretty much have these, it's hard to kind of like set up into individual categories. And I don't want to feel like I am speaking universally about the challenges that others are facing, but there are certainly challenges. Engineering is a very, very, very conservative field still. I faced all kinds of challenges in terms of like anything from pronouns, right, that just drive me nuts, right, or to I don't know, like sometimes like getting like a recent thing that I've experienced lately is for example applying to programs right and sometimes getting like no response back, right, like not really. So these are, for example, programs that might be designed for women in leadership, right? And you submit an application and you're, I think the term would be ghosted, right? Like you don't actually respond and you're like thrown back, right? So there's things that you perceive that are definitely there that you think is kind of weird. Am I the only one that is experienced these? Are others? And there are things that are kind of like in your face, like you're experiencing right then and there and now, and they're very obvious. And I feel like I can deal with the ones that are right then and there because I feel empowered to do so. And I think that I have a support system that allows me to do that. I have a university that backs me up and so on. But I feel like there's probably all these underlying areas of potential discrimination or differences that I don't even know are existing.
Yeah, it's kind of in the soup. Yeah, it's
in the soup, and it's probably happening, right? But you're just not even aware about them, and that's the ones that I think are more dangerous, right? Because nobody, I mean, if it's not evident, right, then there's no way of proving that there is a problem, or there's not even awareness that there is a problem. So that is really a huge challenge. And I think that this is not just for LGBTQ, right? But it extends to women, to minorities, and so on. So there's probably a huge a huge opaque level of challenges associated to discrimination that we're not even aware exist.
Yeah, and sometimes how this sometimes discrimination is not a positively occurring thing, but rather the absence of support that comes from, for example, white guys tend to be in the positions of power. They have different relationships with each other, and maybe don't invite the female or the minority student to a conference or to a lunch meeting. And it's not necessarily it's the person who's doing it rarely feels like they're doing something nefarious, but it's the fact that there's this automatic kind of segregation to like individuals, and then as a consequence of the fact that white dudes are in charge of so much of cultural and political power in the U.S. that it's kind of a and that's like the least pernicious form, but it's almost the most ubiquitous form of discrimination.
And it's like, what do you do to tackle that, right? Like, like there's no clear way of essentially like resolving, or at least I don't have a clear way of resolving that kind of situation, other than I mean, I don't know, like the training, education, like, and it's education at the earliest levels, right? Like it's about how you raise a kid, right? Like it's not even when they're adults already, like they've been formed as people. And
and I think that there's a civilizing influence of art and culture, and the more diverse voices that are that we hear from and that are empowered to speak, I think the better off we will all be. I have a few closing kind of questions that I'd like. I want to be respectful of your time. We have about 9 minutes left. But sure, here we go. How should letter writers for promotion and tenure files be decided?
Oh, that's a great question. So I obviously I agree. I mean, there is something to be said about the way we decide on letter writers, right? That should have ideally no ties to the candidate, and they should be. I mean, you should at least have some unbiased assessment, right? Like of the candidates. But my caveat about this is essentially about diversity, equity, and inclusion also. I think that there ought to be policies that ensure that the letter writers that are being asked are essentially representative, right, of the community at large, and that they're going to be, they're not going to be essentially, I don't know, like overrepresented in one or multiple different forms. So I don't know how you would actually implement this. I have some ideas, but I don't know how implementable this could be. I mean, there could be a check right before letter requests for reviews go out. That could be done at the college level. I mean, most colleges now also have a diversity, equity, and inclusion, either associate deans or committees. Sometimes departments have these too. And there could be a check, right, about, okay, well, are the letter writers that are being solicited representative or likely to be a fair and unbiased assessment of the candidate? So I'm sure that there are things that could be done to make sure that that the chairs and the committees that are actually selecting these letter writers are putting a lot of thought into who these people are and where are they coming from and how do they actually represent the community, right, in terms of assessing a candidate.
Should undergraduate engineering students seek business training?
For some of them, for sure, I think. I don't think for universally, right? Like I have been a major proponent of entrepreneurship. I am excited, and again, this was in my own interest in understanding what are the steps to translating a technology from the lab into the real world. I've learned a lot about entrepreneurship. I've mentored many student groups in entrepreneurship, and many of these students have essentially sought business training, right? They've either taken essentially courses to complete a specialty, and they've enriched their education by participating in these courses. Now, these students were not forced to engage in entrepreneurial projects. They self-chose, right, themselves to make that part of their capstone experience. So I don't think that universally is necessary for everyone. In chemical engineering, there are basic courses, right, in engineering economics and design that I think are adequate for a good number of the students that are eventually serving in industry. But for those that actually do have that interest in technology translation, I think it can be incredibly rewarding to get that experience. So for a fraction of them, yes, I guess the answer
Excellent. How often are you checking your home solar energy production these days?
So I was checking it a lot more than I am right now. I am now satisfied that it actually is working. There's little I can do to make it work more efficiently anymore. And now the weather in Seattle, it looks like it's starting to turn also. We're starting to get a few more days of clouds, and the evenings are coming in earlier. So I am dealing with the fact that it's going to be producing less and less every day now. But I am satisfied actually with my investment. I think that the system is actually providing around like maybe 85% of the power we consume.
That's great.
And not quite 100%, but it's everything that we could actually pack into our roof. So
yeah, we had ours installed a few months before our daughter was born, and I insufficiently accounted for the increased energy demands of a baby and toddler in terms of washing machine, portable AC, space heaters, that kind of thing.
Are you able to get closer than 80%?
I think I'm around 80%.
Okay. Yeah, fortunately we don't have AC needs and things like this in Seattle. So, well, at least not until recently. Now
right.
We've had a heat wave this year, but yeah.
And finally, have you figured out why your Gen Z daughters are playing CDs?
I think that they are just mesmerized that this thing existed, and that was the way we used to listen to music. So yeah, so my oldest daughter discovered that we actually had a CD collection, which are all the CDs from the college years that we've accumulated before transitioning to Spotify and Apple Music and things like that. And they're just amazed that was the way we listened to music. And it's so different for them than it is for us, right? Like they haven't had the experience of listening to a record from beginning to end. Like now it's so much more usual for them to just listen to a song that they like. And yeah, so she was surprised actually when I told her that, yeah, we don't have any CD players, but you can play them on the Xbox and you can play them on your computer and you can play them on all these other places. that she was surprised, like, oh, okay, I can listen to the CDs then. I don't actually need a CD player. But yeah, it's interesting.
Wonderful. I need to come up with a new example to teach embossing, photolithography, and replica molding in my Intro to Nanoengineering class.
Yeah, exactly. Are you still using CDs and they don't know what?
I am, yep.
Yeah, what else, right? Like, can you do?
All right, Lilo. Dr. Lilo Pozzo, thank you very much for joining us. It was a wonderful conversation.
My pleasure.
Thanks for listening to Ideas in STEM Ed, a production of the Idea Engineering Student Center in the Jacobs School of Engineering at UC San Diego. This episode was edited and engineered by Sky Lee, with theme music written and performed by John Viviani. Title art was created by Caitlin Wong. Special thanks to Sarah Eckert for guest booking and marketing. The Idea Center works to promote community, success, and inclusion at all levels. To reach us for guest suggestions and other feedback, please send an email to ideadirector@eng.ucsd.edu. And to learn more about our programs, visit jacobschool.ucsd.edu/idea. As a final note, the views expressed by me or the guests do not necessarily reflect those of the Idea Center, the Jacobs School of Engineering, or UC San Diego. See you next time.